Here's a problem from out of section 2.3 that asks us to take the fourth derivative of this function f of t. We spoke in class about a situation like this. If you're asked for a fourth derivative, there's really no way to get to it unless you have the first, second, and third derivatives in place already. So basically we're just going to start with our function and we're going to have to do four derivatives of it. Now this function presents a bit of an issue because we can't do the derivative of a product. What we can do is we can go ahead and take care of the product. So I'm not taking the derivative yet, I'm just simplifying my function. I don't like roots, I'd rather see exponents, so I'm changing the square root to a 1/2 power. And now if I FOIL these together, I'm looking at first times first, multiplying like bases, add the exponents, 2 plus 1/2 would take you to 5/2. Outer times outer would take you to t cubed. Inner times inner, minus t to the 1/2. And then last times last, minus t. This is just f of t. We haven't taken a derivative yet. Now that the product's out of the way, we can go ahead and we can begin to take our derivatives. So f prime of t, the first derivative of this function, using the power rule, I'm just going to multiply by that exponent and subtract 1 from it. So 5/2 minus 1 would take me back to 3/2. I'm going to multiply by this exponent, subtract 1 from it. I'm going to multiply by this exponent, subtract 1 from it. It'll become a negative 1/2, and then if I multiply by this exponent I get a minus 1, and then if I subtract 1 from it, it's a t to the 0. T to the 0 is just 1, so I don't have to show it. So this would be my first derivative of this function. Now that we have the first derivative, we should be able to go ahead and take the second derivative. So f double prime of t. I'm going to have this coefficient times that exponent. If I do top times top, that'll take me to 15. Bottom times bottom, take me to 4. Subtracting 1 from that exponent takes me to 1/2. If I apply the power rule to this piece, exponent times coefficient, subtract 1 from the exponent, it's now a t to the first. Negative times negative, when I do coefficient times exponent, gives me a positive answer. 1/2 times 1/2, top times top, bottom times bottom, leaves me with 1/4. Subtracting 1 from that exponent should take me back to negative 3/2. Derivative of the negative 1 is going to be 0. Derivative of a constant is 0. I can put that on, I don't really have to. Right? I could have put minus 0 plus 0, whatever. It's gone. It's out of the way. Right? So now we only have 3 terms left. And when we take our third derivative, f triple prime of t, I'm going to do this coefficient times that exponent. So top times top leaves me at 15. Bottom times bottom takes me to 8. And if I subtract 1 from 1/2, I go back to negative 1/2. This is a t to the first, so if I do exponent times coefficient, I'd get a plus 6. If I subtract 1 from that exponent, it's a t to the 0. So if it's t to 0, it's a 1, and I don't have to show it. And then the derivative of this piece, well, it's a positive times a negative, so my answer is going to be a negative when I do coefficient times exponent. Top times top is going to give me a 3. Bottom times bottom is going to give me an 8. And then I can go ahead and subtract 1 from negative 3/2 and end up at negative 5/2. And then finally we'll get to our fourth derivative. And when we take a fourth derivative, we don't typically put 4 primes up here. We just use the notation that the book gave us when they asked us to do this question. This would denote the fourth derivative of f with respect to t. And we're just going to take one more derivative of this. So if I do coefficient times exponent, positive times the negative gives me a negative answer. Top times top leaves me at 15. Bottom times bottom takes me to 16. If I subtract 1 from that exponent, it takes me back to negative 3/2. Derivative of a constant is 0, so this piece is out of there. And then if I do the derivative of this last term, negative coefficient times negative exponent gives me a positive result. 3 times 5 for top times top is going to leave me at 15, and then bottom times bottom is going to leave me at 16. And then if I subtract 1 from this exponent, I'd end up with negative 5 halves minus 1, leaving me at negative 7 halves. And yeah, there's some algebra that you could do with this to simplify it a little bit. You could work with the negative exponents a bit. You could change it back to radical form. At that point, if you chose to rationalize something, you could. I'm concerned with being able to utilize the derivative rules, not necessarily all the algebra that follows. So this is good enough for me.